Hey friends, did you know that Azure API Management has a DevOps resource kit that helps you automate the deployment of your APIs into API Management? Using that resource kit, you can create an ARM template that enables you to deploy your API in minutes. In this, the first of 2 episodes, Meow is going to cover the conceptual framework behind it, today on Azure Friday. Hey folks, I'm Scott Hansel and it's Azure Friday. I'm here with Meow, who's going to talk to me about Azure API Management. You got a whole DevOps resource pipeline management system around this. Like, you're really formalizing the way that we deal with API management.
That's right, because when we talk to our customers, one of the most common questions that come up today is that how do I build a CI/CD pipeline to automate the deployment of my APIs into API management? That's why we created this resource kit to help with our customers. So when you start thinking about building a CI/CD pipeline for API management, we'll quickly run into a few challenges. That's why I'm here to talk about it. So what are these challenges? Essentially, we know that organizations today use multiple deployment environments, right, such as dev and production, right? So as an API developer, once I have finished deploying and developing the backend service of my API, right, how do I automate the deployment of my API into API management? That's the first challenge, right? And second, once I have tested my API in a dev environment, right, how do I migrate all the configurations of this API from my dev instance into my production instance? That's the second challenge. Some of these configurations include things like my API definition, API management policies, authentication settings, diagnostic settings, and so forth, right? So how do I make sure that nothing gets lost during the migration, right? That's the second challenge. And third, we know that an API management instance is often a shared asset between multiple API teams, and each of these teams is responsible for one or more APIs, right? So if multiple teams are making changes to a shared API management instance, how do we make sure that they do not step on each other, right? That's the third challenge. So unfortunately, the answer to these challenges is that it depends. There's no one-size-fits-all solution, right? There are multiple factors you need to consider here. First of all, like, what's your team structure? Do you have a single API team or do you have multiple API teams, right? And also, what is your engineering culture? Is it a low-trust culture where you have a central team who's responsible for everything? Or is it a high-trust culture where each API team is responsible for deploying their APIs directly, right? And also, you need to think about how to implement a CI/CD pipeline using your existing tools, right? And finally, obviously, as an Azure service, API management supports a variety of deployment options, right? For example, there's the Azure portal, which works for some customers who have few APIs and who do not need to update those APIs very often. But using the portal is certainly not an automated approach, right? So to automate your deployment, you can use our management API or PowerShell commandlets, right? It works for many customers, but to some others, it feels a little bit imperative, right?
Okay.
We also have the classic Git deployment feature, which we shipped about 4 years ago. It works for some customers, but it also has its limitations. For example, it does not support RBAC, and it does not support partial deployment. If I just want to deploy a single API, I still need to deploy all the files in this Git repository together, right? And also, the files in this repository uses our custom JSON format, which is not consistent with ARM. So finally, there's resource manager templates, aka ARM templates, right? So if you're starting from scratch today, this is our recommended deployment option for a few reasons. First of all, it is consistent with the rest of Azure, right? And second, it is very easy to automate the deployment of ARM templates. And third, ARM templates, they are declarative and idempotent, right? And also, if you modularize your templates properly, it allows you to do partial deployment, gives you a lot of flexibility, right? And finally, ARM natively supports RBAC, right? So with that being said, let's take a look at a suggested approach of implementing a CI/CD pipeline to automate the deployment of your APIs into API management using ARM templates.
All right.
So in this example, let's say my organization has 2 deployment environments, production and development, right? And each of these environments has its own API management instance. So the production instance is managed by a central team called the API publishers, right? And the API developers who work on APIs, they only have access to the development instance for testing their APIs.
Cool.
So the key in this approach is to keep all your configurations in ARM templates. And also, you need to keep your templates in a source control system. So in my example here, I'm going to use Git as an example, but you can use any source control system that you prefer. So if you look at So if you look at here, for my production API management instance, I have a Git repository called the publisher repository, which contains the configurations of this API management instance in ARM templates. And if you look inside the repository, there are different types of templates. First of all, I have a service template, which contains all the service level configurations of this API management instance, such as custom domain names, number of scaling units, managed identities, and so forth. And then I will have a bunch of shared templates for shared resources in this API management instance, such as products, groups, loggers, and so forth, right? And then for each individual API, I will have one or more API templates which contain all the configurations for this API, such as API definition, authentication settings, diagnostic settings, policies, and so forth, right? So each of these templates can be deployed individually. So if I just want to deploy a single API, I can just deploy the API template for this API, right?
Okay.
But I can also use a master template, which links to everything if I want to deploy everything in one shot.
Is that a meta template, a template of templates? It refers to or includes the other two templates?
Yes, it's a template that links to all the other templates, yes. And then for API developers, they will fork and clone my publisher repository into their developer repository. And then they can work on the templates for their APIs and deploy their APIs into the dev instance for testing, right? However, if we think about this approach, there are two challenges here. The first challenge is that we know that some customers, they still prefer to use the Azure portal to configure and publish their APIs, right? So once they have configured their APIs, how can we help them to extract their configurations into ARM templates so they can migrate these changes from their dev instance to another instance, to another environment? So that's the first challenge. So for that challenge, we have created a utility tool called the extractor, which can help our customers to extract their configurations into ARM templates. And then the second challenge here is that we know that API developers, they often work with open API specification, aka Swagger files, right? So they may not be necessarily familiar with the resource manager schema, right? So if I am an API developer and I have an open API specification for my API, right? How can I easily create an ARM template to help me to deploy this open API specification into API management? That's the second challenge. So for that challenge, we have created a second tool called the creator, which can take an open API spec and optionally can provide the policies you want to apply to this API in an XML file. So the tool will take the open API spec and the policy file and convert them into an API template so that you can deploy your API into the API management instance.
So in that context, the API definition expressed by OpenAPI and the expression of the ARM template, which is much more physical while one is more logical, doesn't contain enough context to go fully back and forth. It's not an idempotent experience. So you have to add additional metadata during that point, and that's the XML file, the policy that goes along for the ride.
So the policy is API management policy, but we also have a configuration file, which is exactly what you're talking about for this tool. So I will show in a minute.
Okay, great.
Yeah. Cool. So once the API developers have their API templates created, right? Once they have deployed their APIs into the dev instance for testing, right? Now they can submit a pull request back to the publisher repository, right? And this is when the API publishers can validate the templates in this pull request. They can validate if the templates are safe and compliant, right? And a lot of these validations can be automated. And after that, the pull request will be merged, the template will be added to the publisher repository, and the changes can be published to the production instance, right? So this is the conceptual framework. So if we think about it, there are multiple benefits here. The first one is that since everything is in ARM templates, right, it is very easy for you to automate the deployment of your APIs, right? And second, again, since everything is in ARM templates, it is very easy for you to migrate your changes from one environment to another environment, right?
Okay.
And third, because different API teams, different API developers will be working on different API templates, different files, right? So it is less likely for them to step on each other. And finally, this is a very flexible approach. You can easily adjust it to fit your own requirements. For example, you can use different tools to implement this flow. You can easily add a different deployment environment here. Or instead of having a central API publisher team, you can also allow each API development team to deploy their APIs to the production directly, right, with proper RBAC setup. So it's a very flexible approach. And everything I just talked about, as well as the tools, they are published on GitHub at this link. And the tools are open sourced, so you can also customize and extend them if it doesn't fit your needs, right? And also, community contribution is greatly appreciated.
Can I ask a couple quick questions? So one of the questions I have on the development side, while I think things are quite clear on the production side, particularly around the forking and then ultimately pull requests going through the publisher repository, but as I noticed that the API developers are writing API definitions, is the API definition the authoritative source? If we use the term source code to indicate if I could delete something and then build again, I could theoretically delete some of the ARM templates in the developer repository and recreate it again.
Correct.
Because the source is the combination of the API definition plus additional policy metadata.
That's correct. If you delete something by mistake, you can rerun the creator to recreate all your templates.
Okay. So then I would not want to manually ever edit ARM templates in any of the repositories. The source code is on the right-hand side there.
That's right.
That's very clean.
Yeah.
All right, well, we're going to take a break here for part one. This is the conceptual framework about how we're going to do this. And then in part two, we'll put it into practice today on Azure Friday.